Here is a simple challenge. I have two identical cubes. Can I cut a hole in the blue cube large enough for the red cube to pass through? Obviously, if I smash the cube, it's easy. But the cube must remain a single connected solid. Now, what if I told you I could pass a larger cube through a smaller one? It sounds geometrically impossible, but it is 100% real. Let's solve it. To solve 3D problems, we often need to look at 2D shadows. If we look face on, the shadow is a square. Obviously, a larger square can't fit. But if we rotate the cube to its extreme diagonal, the shadow changes into a hexagon. This hexagon is the key. It is significantly wider than the original square face. Let's do the math on this hexagon. The hexagon is actually square root of 2 wide. That's 41% wider than the cube itself. This means we have wiggle room. A square of size 1 fits easily. In fact, we can fit a square that is roughly 6% larger than the original cube. For those interested, here is the quick, rigorous proof. First, consider a unit cube centered at the origin. Its vertices are at plus and minus 1. The space diagonal connects -1, -1, -1 to +1, 1, 1. Projecting the cube perpendicular to this diagonal results in a regular hexagon. The width of this hexagon can be calculated as exactly 2 times the square root of 2. This width allows for a maximum inscribed square approximately 1.06 times larger than the cube side. Now we return to 3D. We align the cube along this magic diagonal. We create a tunnel shaped like our slightly larger square. We subtract this tunnel from our cube. It looks like it fell apart, but wait. These 4 tiny pillars are still holding it together. Here is the moment of truth. A cube passing through a smaller cube. This is not a trick of perspective. It is a trick of geometry. The larger cube can be exactly 1.06 times larger. This puzzle is named after Prince Rupert of the Rhine, who supposedly won a wager with this trick. Since the inner cube is larger, you could theoretically chain them forever. Math is full of impossible things that are actually true. Subscribe to see the next one.